Hey everyone, welcome to How to Determine Where a Function Increases or Decreases. This is Nicholas JMV. Okay, so before we get started on our examples, there's a couple things that we need to just to clear the air with and make sure we understand before we do these problems. So there's the two examples we're going to do. But before then, in order to help us determine if a function increases or decreases, we're going to look at the critical values. Okay, and so that's where your function, your derivative, equals 0 or is undefined. Okay, that's one thing we have to look at. We're also going to look at and realize that if your derivative is greater than 0, f of x increases. And if f prime of x is less than 0, f of x decreases. This is the idea we're going to take into these examples, these three things, okay? We're going to look at the critical values first and then see the values of our derivative to see if they're greater than 0 or less than 0. So let's take these ideas into our example. Okay, so let's find the intervals of increase or decrease, if any, for the given functions. We're going to start with f of x on the left. Now that is a polynomial function. Okay, so it's differentiable everywhere. Okay, so we're going to look at f of x is equal to 2x cubed minus 24x plus 1. So let's take its derivative. So f prime of x is equal to 6x squared minus 24. Okay, there's the derivative. We need that because we got to figure out where the values are greater than 0 and less than 0. So the other thing we need to do is look at the critical values. So we have to set our derivative equal to 0. Okay, and we're going to go ahead and do that, and then we're going to factor out a 6, and we get x squared minus 4 inside. And so x, we can simplify this more, difference of two squares. So we're going to know that x equals plus or minus 2. And those are our zeros. Those are our critical values that we need. Okay, so what we're going to do now is we're going to create a number line. So I'm going to go ahead, and this differs by whoever's teaching it, really. Okay, so I've got negative 2 and 2, and I'm going to go ahead and put x plus 2 here, x minus 2, and then our value of our derivative. Okay, so let's just pick a value. If I pick a value greater than 2, I know that this is going to be positive. Anything greater than 2, this is always positive. Okay, so that's positive. Okay, and what we're going to do now is if we pick a number greater than 2 here for this one, x minus 2, like 3, 4, 5, 6, this is also positive. So a positive times a positive, because this is multiplication, is a positive. So there we go. A number between negative 2 and 2 is 0. So if you plug in 0, 0 plus 2 is 2. That's a positive. Okay. And if you plug in 0 into this, 0 minus 2 is negative. And if you multiply negative and a positive, you get negative. Okay? And left of negative 2, like negative 3, well, those are always going to be minus. This is going to be minus, so this becomes plus when you multiply. Negative 3 plus 2 is negative 1. And that's the case. So look what we have here. So we know that from negative infinity to negative 2, and from 2 to infinity, f of x increases. Okay? And then we know that in between, from negative 2 to 2, f of x decreases. So there we go on the first example, okay? So we're looking at making a nice little number line. All right, so let's look at example number 2 and see what we have here. So we have g of x is equal to 1 over x plus 1. So here's the thing. So let's look at this function. All right, well, we got it. So look, g of x is equal to 1 over x plus 1. Okay? G prime here is going to be negative 1 over x plus 1 squared. Okay? Notice that in both cases, x cannot equal negative 1. Okay? So there are no other zeros. There's no other way to make this 0 because the numerator is a constant. So there are no critical numbers at 0, but we have to look at the numbers that are undefined. So if I look at just -1, that's the only number not defined. Okay, and I take the x plus 1 squared, and I can look at g prime of x. Okay, when we start plugging in numbers, it doesn't matter what I plug into here. It's always positive. Every number, whether it's positive or negative, this is always going to be positive. But because of this negative, this is negative, this side is negative. So meaning, from negative infinity to -1, in union with -1 to infinity, g of x decreases. There is no interval where this function increases. Okay, so there are a couple of examples I've just shown you on how to determine where a function increases or decreases. If you have any questions or comments, let me know. We'll see you next time.